Before we jump into any programming, let's picture a small scenario. Here I have a player and a dice. Let's say that if the dice lands on a 6, the player gets a point. This isn't too complex, and modeling this with code isn't that complex either. We have two basic objects here. The dice object performs some action and then calls a method inside the player object. This model works perfectly fine, and for our example with the one dice and one player, you won't run into any issues. But what if you want to add another player? Well, then you'd probably have to add another method call inside the dice object. But then what if you want to add another player on top of that? And then maybe another dice. And what if a player leaves halfway through the game? Things start to become harder for us to model inside a program, and what we originally coded up doesn't scale that well for multiple dice and multiple people. But luckily, that is a problem that many others have had as well, and for us that means there's a good solution for it. The observer design pattern has two fundamental parts to it, the observable and the observer. I like to think of the observable as the actor. This is the object that changes or performs some action of interest. This object also maintains a list of all observers and notifies them whenever some change occurs. In our original example, this would be our dice object. The second half of this design pattern is the observer. I like to think of this as the watcher, since it reacts to some change inside the observable object. In our original example, this would have been the player object. This is what it looks like in code. Everything here is essentially all you will need to use this design pattern. Inside the observable, the first thing you have is a list of observers, just like we talked about before. Here we use a list and not an array, because we want to be able to add and remove observers dynamically, which an array won't let us do. We also have a register and unregister method, which allow us to add or remove observers from our list. And finally, we have a notify method, which is where the bulk of our design pattern's work happens. This method is usually called after some event happens, like a dice being rolled. Inside this method, you have a for each loop that goes through your list of observers and calls update on each one. Inside the observer, which is a fairly short class, all you have is your update method. The parameters for this method are normally going to be the value of interest, like the new value that was just rolled, but you can also pass in the entire observable object if you want more flexibility. There really isn't any right or wrong approach, as long as you include whatever you need for your specific solution. Now, let's go back to our dice game example and add some labels to it. Like we mentioned before, the dice in this example is our observable, and the player is our observer. In order to connect our player with our dice object, we have to use the register method. We call register on our dice object and pass in our player as a parameter. What this will do is add our player to our observers list. And we don't have to have just one observer. We can add as many as we want to. Whenever we call notify on our dice object, we use our new dice roll as the parameter. Inside this method, we then loop through all the player objects inside our observers list. On each of them, we call the update method and pass along that same parameter. Now, if we wanted to remove a player from observing our dice object, we would call the unregister method, which would remove that specific player from our observers list. Another cool thing is that each of our observers don't have to be assigned to just a single observable. We could have two dice objects, and each of them can register our players so that when either of them performs some action, both players are updated. There is some useful flexibility on each observer as well. Each update method for our observers doesn't have to be the same. Different observers could respond to different things. So I could have one that only reacts when my dice roll is a 6, or whenever my dice roll is odd, and so on and so forth. The reason why we're able to do that is through subclassing, so we could make as many observers as we want to, and have them all implement a common interface, and allow each one to be used interchangeably. So whenever we call the register method on our dice object, we could pass in observer A and observer B in the same exact way, because they share that same common parent interface. In conclusion, we learned that one observable can have many different observers, and likewise how one observer can watch multiple observables. We also learned how you can use subclassing to make the update method in each observer conditional to give us more flexibility. Thank you for watching.